My name is Muhammad Zikri bin Zulkipli and my number matric is B0220101191. And next.
Okay. Assalamualaikum and good day to you. My name is Aiman Zhafran bin MUSTAFA KAMAL, B022010 and 200. And next.
My name is AHMAD ADZMI. My metric number is B0220101212. And this is our project for social distancing awareness machine.
Okay, let's get on to the objective. Our objective in this assignment is to make users aware of the need for social distancing in the current virus situation, as in this COVID-19 situation. And number two, make sure people around us know about our social status in preventing the virus from spreading, which is we hold on tight to the rule of social distancing, which is to stay away from each other within 6 feet. And number three is to reduce the amount of infection around the area. And after that is the problem statement. This project was invented based on the challenge that we had during this COVID-19, which is, as we all know, despite all the warnings that have been given from the government, there are still a lot of people that purposefully break the social distancing rule. This is why we make our assignment as a social distancing awareness machine. For the methodology, basically just basic kind of thinking, which is the first step. We brainstorm the ideas based on from the problem statements and the objective. Second step, we design the prototype with the software, Fritz software, which is easy to use. And third step, we code the microcontroller that will be used, which is the LPC1768, by coding the microcontroller in Kill software. And the fourth step is record and compile all the data acquired, which is basically a report making. Next, I will give to AJWAD momentarily for the flowchart.
Hello. For the flowchart for this project was shown in the figure beside the text. The machine will start by sensing the distance of any obstacle from it. In this situation, the obstacle is other people. Then, if the obstacle distance is within 2 meters from the machine, the buzzer will be activated. But if the obstacle distance is more than 2 meters, the buzzer will stay silent. Then the machine will stop.
Thank you very much, AJWAD. Next one is Muhammad Zikri. Take away.
Okay. For the first component is LPC 1768. NPC 17668 was founded by Philips. It is a 32-bit Cortex M3 ARM microcontroller with MPU. The NPX LPC 1768 microcontroller is ideally designed to create prototype for all type of devices, especially those that included Ethernet, USB, and many peripheral interface and flash memories. Next is second component is ultrasonic sensor. An ultrasound sensor is an electronic device that measures the distance of a target object by emitting ultrasonic sound wave and converting the reflected sound into electrical signals. Ultrasonic wave move faster than audible sound speeds. Next is buzzer, an audio signaling device which may be mechanical, electromechanical, or piezoelectric. Piezo for short. Typical uses of buzzers and beepers include ARM device, timers, and confirmation of user inputs such as a mouse click or keystroke.
Okay, thank you for that, Zikri. I will now give away to Muhammad AJWAD back. Ahmad AJWAD back for the software and codings. Take away.
Thank you, Amirul.
Aiman.
Pause. Ikat.
I don't mind, don't worry. Keep on.
For the software, we use Kyle software. Kyle software is provided a wide range of development tools such as ANSI compiler, macro compiler, debugger, and simulator, connector, IDE, library manager, real-time operating system, and evaluation board for Intel 8051, Intel MCS 251, ARMS, and XC16X, and family STD10. Next. For the coding, we use ARM assembly language. An installation program language is a low-level developed using mnemonic. The microcontroller or microprocessor can only understand binary language such as 0 or 1. Therefore, the assembly convert the installation language to binary language and store it into memory to perform tests. The register R0 to R4 is used to load the address of the I/O register. R1 is for PINSEL0, R2 is for FIO0DIR, R3 is for FIO0SET, R4 is for FIO0CLR, and R5 is for FIO0PIN. The register R5 was used to load the value of 0000 into the R0 register to set the pin into the GPIO. Then R5 is used to set which pin is input and output based on the value that's shown in the coding, and then store the value into R1, which is the FIO0DIR, to set the input pin and output pin. The R6 register was loaded with the value of 0100 and then stored into the register 2 to set the trigger pin into high. Then a loop was started to count into 5 loop to represent 10 microseconds. Then when the loop ends, the R6 value was used again to set the trigger pin low by storing the R6 value into R3 register. Then the echo pin status was checked using the AND operation to see if it's high or low. A loop was used to see how many loops it takes for the echo pin to become low again. When the echo pin is low, the loop will end. R8 register was used to count how many loops it takes. Finally, the R8 register value was used to see if the distance is greater than 2 meters or not. If it's greater than 2 meters, the buzzer won't be activated, but if it's less than 2 meters, the buzzer will be activated. After that, the coding will repeat again at the again branch. Thank you. I will give back to Aiman.
Okay. Thank you very much, AJWAD. Thank you very much. As for the next one is our circuit arrangement, which I made in Precision software. This circuit consists of ultrasonic sensors, which as you can see, HCSR04, buzzer which on the right there, and a microprocessor. As explained in the flowchart before, the ultrasonic will measure the distance. Then, based on the condition that's written in the coding, the microprocessor will determine if the buzzer should be activated or not. The condition is the distance should be less than 2 meters for it to be activated, and it will produce a beep. And I will give back to Muhammad ZIKRI for the conclusion of our assignment. Take over.
Okay, thank you, Aiman. For the last part is the conclusion. As all may know, we are currently experiencing a terrible pandemic all around the world. Precautions warning rules and safety measures have been notified to the people all around the world to stop this virus from spreading and make the world an even worse place to live in. As known, the precaution that needed to be kept in mind all the time. With that, we can say for good that it will keeping us safe from spreading virus. But despite all the warnings, sometimes human can be a tad clumsy. This is where machinery comes into place. Machines have helped humanity for the longest of time, and without a doubt, they can help us even in this pandemic. It just matters of making it a reality or not. As a result, from this project, we can show that innovation of machinery in helping humanity once again put a stop to this pandemic. Okay, thank you.
Okay, with this, our assignment presentation is done. Thank you very much for the attention, and have a good day. Thank you very much.